As fate would have it, my kids got to go back to school today on Tuesday, and I got to not go to school with you guys, but I'm in school anyway. I'm filming this from my classroom. We're going to be going through the exam review. I'm going to be putting up a bunch of tapes on this. What I really want you to get out of this is using it as a secondary review device. I posted it at the beginning of Christmas break. I wonder how many of you even noticed that. But what it boils down to is everything on the practice exam that we're going to cover the next 3 days of exam review days has something here on these pages. On the practice exam, I've identified the sections that everything can be found that you are working through. On the exam review, I probably won't do that on this film, but I will mention where I think it is, I guess, in terms of what section. But this is additional examples that you can kind of work on and check yourself as you're going that will help understand what's on the practice exam. And keep in mind the practice exam is very similar to the real exam. In fact, the real exam is shorter. So we're going to kind of chunk away at that. We're going to hopefully use these videos and hopefully figure some things out that we could not recall before. With that being said, let's just go right into it. As you can see, I've already kind of started on number 1. I distributed the 6 into each of these terms. I distributed a -4 into each of these terms. And negative times a negative, of course, gave me a positive here. And then I just combined like terms. Now, this is kind of a bad example because there is no standard form and I've got 2 different variables. I won't do that to you on the exam or on the exam review, or the practice exam for that matter. But just bear with me here. 6a minus 6a cancel each other out. All I'm left with is this -4a, and I've got a -18b and a 12b. Different, so I subtract to get 6 negative, because the bigger number is negative, b. And I guess for the leading coefficient, I'm not even going to put something here. You could put -4, you could put -6. It depends on how you wrote it, I guess. We'll get to that kind of later in terms of what it is. There is 2 terms here, so I guess I'll call this linear because there's no squared terms, and binomial, because there is 2 terms. That at least we can say. Okay. If I look at the next problem, this is going to be a bit of work, and the one on the exam is not near this difficult, but it is going to take a little bit of work. This is x minus 3 times x minus 3 times x plus 3 times x squared. And I just rewrote this out here. And I also know that this right here is difference of squares, so I'm going to combine those a little easier. X minus 3 times x squared minus 9, and then times x squared, right? I'm just going to distribute that in here and then just FOIL it out. So I'm going to have x minus 3 times x to the 4th minus 9x squared. And again, all I did is distributed this entire term into here and into here to get those 2 terms there. And now it's just a FOIL problem. First, x to the 5th. Outside, I get an x to the 3rd, excuse me. I want to do this one next just to keep it in order. -3x to the 4th, then -9x to the 3rd, then plus 27x squared. Okay. I could have did this into here if it was a little easier for you. Really, it doesn't matter. We get to this point, you can see the leading coefficient here is the term in front, and that term is 1 when there's nothing there. And this is called a quintic polynomial of 4 terms. On the one that the key itself that I post on Google Classroom for the practice exam, I will have listed all of these terms on here, but this is from 5.1b. 5.1b, that one I remember off the top of my head. Next problem, I'm going to FOIL. So first is x squared. Outside is -4x. Inside is positive 5x. Different. So I subtract to get 1. Bigger number is positive x. And then minus 20. Leading coefficient again here is 1. I feel like this is a little bit confusing in the review. It'll be better on the practice exam. If there's whatever number here is what goes here. When there's nothing there, it means 1. But whatever number is there is your leading coefficient. The number of terms is trinomial because there's 3. And it's led by x squared. And that's one that everyone in here should know. The word quadratic, because we spent an entire chapter 5 and some of chapter 6 on it. Next set of problems, this was really just algebra review stuff that we did basically the rest of this page. Like the first 3 weeks, 3 weeks of school we did this stuff. Hopefully you remember how to do this stuff. I'm going to kind of fly through these problems. -5 to both sides. We always do the opposite of addition and subtraction first, then we do the opposite of multiplication, division second. It's kind of like PEMDAS backwards. So I get 10 equals -2x, and divide by -2, of course, to get -5. Okay. I'm going to bring x to one side and number to the other side. Again, this goes back a couple years for most of you, hopefully all of you. I'm going to -3x to both sides, and just to save room, I'm going to do the -20 at the same time. I like this too because what I do is I end up crossing out x on one side and number on the other side, and I can just see what I have left. These are both negative, so that's -27. Subtract because they're different to give me a 3x, and divide to get -9. Okay. Here I'm going to -5x at the same time. I'm going to add 14 at the same time, and I get 21. Oh, those cancel too, so equals 0. And when 21 does not equal 0, see the rest of these got x equals, the other ones will as well, by the way. When I get this and there's no variable, those don't equal each other, so that's that, just the 0 with a slash through it, undefined. Okay. Over here, combine like terms first. I've got a 5 and a -12 to give me -7w. Now it just becomes just like that problem, really. I like to keep my variable positive, so I'm going to add 15w to both sides. And so I'm going to do the opposite of the other side here to get those to cancel. So I get 8w equals, well, 8, and w equals 1. And then distribute here. Combine my like terms. Combine my like terms on this side as well. -14 plus 8a, or 8a minus 14, however you want to write it, minus 3a to both sides. And I'm going to plus 14, so I got something on one side and some number on the other side. 5a equals 15, and divide to get a equals 3. Took us a little work there. Rather lengthy problem, but that's all stuff you should be able to do. Right here, I distributed again a -1 into both terms there. That's why this became a -1a and plus 1. Okay. On to the graphing problems down at the bottom of the page. And again, this is just going to be one page at a time so that these aren't too long. We're at about 7:40 now. We should get by 10 minutes. This gives me standard form of what we said, that's ax plus by equals c form. So I could just do the cover-up method here to solve for those. So here I could just cover up and say y equals -3, which is right here, and cover up and say x equals 4, which happens right here. I could also set the x equal to the number, and that's how I get -4, which I went the wrong way. That's not -4, silly. And 4y equals -12. When I divide, I get y to be -3. Okay, so -4, by the way, is over here. And I just connect my dots. It's that simple. For the next problem, 21 here, where does x equal -2? That's everywhere on this point. This is -2, 2. This is -2, 4. This is -2, 3. -2, -4, etc. Right? So first thing I got to recognize is a less than sign, which means it's going to be dashed. So through this, I'm going to dash my line, and that would be the first step, is recognizing that it's dashed or solid. Which, by the way, when it's solid down below, it's going to be straight solid through it. If it takes more ink to make the sign, it takes more ink to draw the line. Down to y, where does y equal -3? That's here. So similar to the other problem, I draw my line in first, dashed when it's less than or greater than. Then I talk about my shading, and you do that 0 trick. I'm going to talk about that here in 22 as well. If I plug in 0, I get 0 is less than -2. Is 0 less than -2? No, it's not. So I don't shade there, I shade away from 0. So when it's false, I don't shade towards that point. When it's true, I shade towards it. Let's see what this says. 0 is greater than or equal to -3. That is true. So for this one, I shade up. Okay. For this next one, it's kind of a combination of both. I'm going to do the same trick here, that I did for this, or same trick here that I did for this one. So use the cover-up method. Y is -4 right here. X is 5 right there. And I'm going to just connect those. Now you should probably use a straight edge, but I'm going to be okay with, of course, a solid line because it's less than or equal to. And then I'm going to use the 0 trick again. I'm going to plug in 0, 0, get 0 is less than or equal to 20, which is a true statement. So that means 0, 0 is part of the solution. So I got to shade that line towards 0, 0, and all this stuff gets colored in. Okay? If you struggle with this stuff, it's way back at the beginning of the semester, probably into the last week of August that this information is on, maybe first week of September. Go check that stuff out. And on standard, it was right before we started linear programming. Okay? All right, that's it for this page. Check out the next one.